Okay, let's go ahead and go through the test first. And that way we can go on and get to where we're supposed to be. You guys just finished test 3, correct? Okay. I'm going to go through this quickly because we are going to try to do the feather lab. So I'm going to go through this quickly. I know I didn't plan on you doing it, but then I did it and thought it was fun, so I brought the stuff. So we're going to try. Did you any of you do it at home? No? Did you, Piper? It's kind of neat, wasn't it? It surprised me. And I thought, wow, we might kill each other stepping over each other trying to do it, but we're going to try it anyway, okay? All right, so I'm going to run through this quickly, like I said, and if you guys have a question, please stop me because I will be happy to go through anything I need to in more detail. You've already brought some things to my attention that I wasn't aware of, so I really covet your help, okay? And I just want you guys to know that. So radioactive decay, you should have had something about the breakdown of the atom's nucleus. So you could have said spontaneous breakdown of the atom's nucleus that causes changes to the element, or you could have just said that it's a breakdown of the nucleus. Or what I used to like to define it at in physical science was just an unstable nucleus of an atom. Yes, sir?
If I put spontaneous breakdown of an atom, like or is the nucleus of an atom?
It should be the nucleus because it's not the atom itself, so take off half, okay? Okay. Physical constant, something about a quantity that doesn't change. I don't like the word never there. Only God never changes. But something about a quantity that doesn't change. And it uses the speed of light, and some people, that's questionable. Some people believe the speed of light has changed through time. So that's why I don't like the word never. Ground state is the lowest energy state of a particle, and we're going to be using that again in this module, aren't we? So you really do need to know that ground state is that lowest energy state. Spectroscopy is identifying chemicals by studying the light they emit or absorb, and that's a very cool science. All right, number 2, an element has 9 protons. What is its symbol, and what is the mass of the average atom in that element? With 9 protons, we know we go here to the 9, so the symbol would be the F, and then it asked us for the average mass in grams. So you would take the, on your chart, it was 19. Because your chart has different significant figures. It was 19.00, which is different than that. And so you took that 19.00 AMUs and you multiplied it by 1.66 times 10 to the negative 24th grams over 1 AMU. That was your conversion factor. And you should have gotten 3.15 times 10 to the negative 23rd grams. Does anybody need to see that one? Okay. Number 3, an electromagnetic wave has a wavelength of 0.12 meters. What is that in nanometers? You would just take the 0.12 meters times line it, and on the top you'd have nanometers, and on the bottom you'd have meters. I put 10 to the 9th nanometers over 1 meter, but you could have done 1 nanometer over 10 to the negative 9th meters. It was your choice. One way or another, it gives you 1.2 times 10 to the 8th nanometers. Okay, 2 significant figures. Number 4, which light has a higher frequency, yellow light or blue light? What'd you put? Blue. Remember Roy G. Biv? And the frequency increases as it goes towards Biv, and so it would be the blue. Number 5, an anarchist finds some uranium in an abandoned mine. He gets the schematics for a nuclear bomb from the internet and follows the instructions perfectly. He then loads it with the uranium he found in the mine. Will the bomb work?
No.
No. But he doesn't ask why. Do you notice that? It's just no, but the reason why is because he'd have to be able to enrich it. So anyway, number 6, how many protons, electrons, and neutrons are in Cl, chlorine? 37. And so you would find chlorine, which is 17. So how many protons does it have? 17. How many electrons does it have? 17. And then 37, it was 37 or was it 35? 37. It was 37. So how many neutrons does it have? 20, because it would be the 37 minus the 17 is 20. Wow, that was easy math. I can even do that math in my head. Yes, okay. Number 7, which of the following is not a kind of electromagnetic wave? And we had gamma waves, radio waves, gravitational waves, or infrared. Which one? Gravitational waves are not a form of light. Very good. Number 8, what is the most abundant isotope of boron? So we were to look at boron, and we were to look, and your chart is different once again. So your chart, well, actually that number's the same. So it tells us 10.81, and so what would be the mass of the most common one? 11. It would be 11. That would be the most abundant isotope. So your answer, you could have written out boron 11, or you could have put B with the 11 up to the top left, which would represent boron 11. You could have had your answer either way. Okay? He kept saying in this chapter that you just read, though, how chemists are lazy and they want to do everything the short version. And so I would do the B with the little 11 up to the top left. So just so you know, I think he's right. I think most people like the short way if it's at all possible. So. Oh no, don't do that, because that's where the charge goes. Yeah. And each place has a specific thing that goes there, so don't do that. All right, number 9, an electron in a hydrogen atom emits light of wavelength 103 nanometers to get to its ground state. Another electron in another hydrogen atom emits light of wavelength 94 nanometers to get to its ground state. Which electron jumped from the orbit with the highest value of N? And so, which one jumped from the highest one?
The first. The 94 nanometers.
Actually, I put the 94 nanometers, and the reason I did, let me show you. We have the 103 nanometers, and we have the 94 nanometers. This one has a longer wavelength, doesn't it? If it has a longer wavelength, then it has a lower frequency. So it's a lower energy light. Does that make sense? Because remember, frequency equals the speed of light over the wavelength. So if we have a longer wavelength, we have a smaller frequency. And remember that the energy was HF, Planck's constant times F. So that would be a straight thing. So this would be a smaller amount of energy than this one would end up being. That's what they were looking for. And so because it would have a smaller amount of energy, the 103 isn't the one with the highest N value. It would be the 94. The shorter wavelength would have the higher frequency, therefore the higher energy, and therefore that would be the answer for the higher value of N. Does everybody understand the logic there? Okay. Number 10, what is the frequency of green light, which has a wavelength of 511 nanometers? And so for that one, I got 5.87 times 10 to the 14th hertz. Does anybody need to see that one? Okay. We good? Number 11, what is the wavelength and energy of a photon with the frequency of that? There was 2 steps to this. First, you figured out what the wavelength was. And then once you figured out is that right? Wavelength and energy. Yep. First you figured out what the wavelength was, and then you could go and figure out what the energy was. The wavelength was 4.57 times 10 to the negative 15th meters. That's what I got. If you put it in nanometers, it would be 2 different than that. Did anybody do it in nanometers? No, we good? Okay. And then the energy is 4.36 times 10 to the negative 11th joules. Are we okay? Good. All right, number 12, an electron in a hydrogen atom absorbs a photon with a wavelength of 486 nanometers. Did the electron move to an orbit closer to the nucleus or farther away from the nucleus? If it absorbed energy, did it jump up or did it jump down? It jumped up, right. So it had to get farther away from the nucleus, didn't it? Very good. All right, 13. What is the energy difference between the orbits involved in question number 12? And so if you did the math there, because in number 12 you were given the, what is the energy difference? Okay, so you did energy equals, and you put in Planck's constant, and then you put in the frequency that you calculated from 486, nanometers, and you should have gotten an answer of, for your energy, 4.09 times 10 to the negative 19th joules. Does anybody need to see that one? We're okay? All right, number 14, sodium's emission spectrum has a bright yellow line at about 589 nanometers, which we saw. Anyway, if you pass light through sodium and examine the wavelengths that pass all the way through, what would you see in the spectrum of 589 nanometers? A dark line, that's right, no light at all. Thank you. 15, an atom has 91 protons, 145 neutrons. How many electrons does it have? 91 electrons. And what is its mass number and its symbol? Okay, so it's got 91 protons, and so its symbol is Pa. Is that what you guys got?
Yep. Yeah.
91. There it is! Way down here at the bottom. He's making us work for it, isn't he? And then the mass number would be 236. You would just add the neutrons and the protons. So it's Pa 236. And then what is the approximate mass in AMUs of an atom in question 15? So here you would...
Wait, why would the mass number be... Wait, what did you get for the mass number again?
236.
Why would you get 6? We got
91 plus 145. 91, sweetheart.
Yeah.
Look at number 15 on your test. Don't even look up there. It says it has 91 protons and 145 neutrons. You have to add those two numbers up.
Okay.
So that gives you
I got
236.
that 91 protons, but then I didn't get that one, so it only take half or how many points?
Take half. Did you get the right symbol?
Yeah.
Take off a third. There were 3 parts to that answer. And then, boy, I hope that's how let me just see how he did this. Just a half for the electrons, half for the symbol, and a whole for the mass. Rats.
So take off one whole.
Just take off a third. We'll figure it out. Let's see. And then the last one, which is 16, is just 236 AMUs, right? The sum of the protons and the neutrons. Yes, ma'am?
Can we go back? Okay, so number 3, I did the conversion right, and I got 0.12 times 10 to the 9th nanometers. I didn't put it in the correct significant figures.
That's fine. That's fine. Just leave it alone. If you showed everything, just leave it alone. Okay, he's got
What was the last one again? Number 16.
236 AMUs.
If I didn't put AMUs,
Just let it go this time, but start putting it down behind everything, okay? Okay, now, he's got each of these worth 4 points, but some of them, like he's got them worth more. Hang on, 16, 17, 18, 19. If we made everything worth 5 points, it'd be easier. So make everything worth 5 points, including the vocabulary. So every answer is worth 5 points. So if you missed on what you did, take off 2 points, because we'll make that one worth 6 points, okay?